Dr. David Kipping, an associate professor of astronomy at Columbia University, discusses the search for extraterrestrial life and our place in the universe. He emphasizes the importance of intellectual honesty in addressing the question of whether we are alone, stating that the most accurate answer is simply, "I don't know." Kipping cautions against overconfidence and experimenter bias in this field, advocating for a forcibly agnostic approach. He acknowledges the cognitive dissonance inherent in both possibilities, that we are either alone or surrounded by alien life, noting that both scenarios seem equally preposterous and terrifying. Kipping explains that while the universe may be teeming with simple microbial life, our current technology, even with advanced instruments like the James Webb Space Telescope, is not yet capable of detecting biosignatures on exoplanets. He suggests that the absence of evidence for galactic empires or advanced civilizations raises intriguing questions about the rarity of intelligent life evolving beyond simple forms. The conversation touches on the Fermi Paradox, the apparent contradiction between the high probability of extraterrestrial civilizations existing and the lack of evidence for them. Kipping discusses various explanations, including the possibility that advanced civilizations may choose to inhabit virtual realities rather than expanding physically across the galaxy. He mentions the idea of a survival instinct driving civilizations to colonize other planets and stars, yet notes the puzzling absence of observable galactic empires or Dyson spheres. Kipping explores the concept of the mediocrity principle in astronomy, which assumes that Earth is not special or unique in the universe. However, he points out several ways in which our solar system appears to be atypical compared to observed exoplanetary systems, such as the presence of Jupiter-sized planets and the arrangement of planets in our solar system. Kipping provides an overview of exoplanet discovery methods, including radial velocity measurements and transit observations. He explains that the most common type of exoplanet discovered so far is the mini-Neptune, or super-Earth, planets larger than Earth but smaller than Neptune. He notes that our solar system lacks this common planet type, adding to its apparent uniqueness. The conversation delves into the history of exoplanet detection, from early attempts in the 19th century to the first confirmed discoveries in the 1990s. Kipping highlights the importance of multiple detection methods in confirming exoplanet discoveries and overcoming initial skepticism in the astronomical community. The podcast explores the concept of advanced civilizations and the Kardashev scale, which classifies hypothetical alien societies based on their energy usage. Kipping explains the different levels of the scale, from Type 1 civilizations that harness all the energy of their planet to Type 3 civilizations that control the energy of an entire galaxy. He discusses ongoing searches for signs of these advanced civilizations, such as Dyson spheres or swarms, which would be detectable through their infrared signatures. Kipping mentions recent studies that have searched for evidence of Type 2 and Type 3 civilizations among nearby stars and galaxies, noting that so far, no compelling candidates have been found. This absence of evidence raises questions about the likelihood of civilizations reaching such advanced stages of development. The conversation touches on the nature of consciousness and the challenges of imagining alien forms of life and intelligence. Kipping suggests that extraterrestrial intelligence might be so radically different from our own that meaningful communication could be impossible. He uses the example of a planet-wide fungal network to illustrate how alien consciousness might be utterly incomprehensible to us. Kipping also discusses the anthropic principle and its relevance to the search for extraterrestrial life. He explains how our existence as conscious observers necessarily biases our perspective and expectations about the nature of life in the universe. The podcast addresses recent challenges to the standard cosmological model, particularly in light of observations made by the James Webb Space Telescope. Kipping explains that the telescope has revealed surprisingly mature galaxies and large black holes in the early universe, which has led some to question the Big Bang theory. However, he argues that these observations can likely be explained by refining our models of early star formation rather than completely abandoning the standard cosmological model. Kipping emphasizes the extraordinary success of the lambda CDM model, which incorporates dark energy and cold dark matter in explaining a wide range of astronomical observations. He suggests that while the new data presents challenges, it's premature to discard the entire theoretical framework based on these initial findings. The conversation concludes with a discussion of dark matter and dark energy. Kipping acknowledges the skepticism surrounding these concepts due to their invisible and intangible nature, but argues that there is strong evidence for dark matter from various astronomical observations. He explains phenomena such as galaxy rotation curves, gravitational lensing, and tidal streams that provide evidence for the existence of dark matter. Regarding dark energy, Kipping admits that the evidence is less diverse and primarily based on observations of the accelerating expansion of the universe. He discusses the cosmological constant, initially introduced and then rejected by Einstein, which has now been revived to explain this acceleration. He notes that the true nature of dark energy remains a mystery and that current quantum mechanical calculations of vacuum energy vastly overpredict its magnitude, presenting a significant challenge for physicists. Throughout the conversation, Kipping provides insights into his career as an astrophysicist and his approach to scientific inquiry. He emphasizes the importance of remaining open-minded and avoiding overconfidence in scientific theories. His work spans various areas of astrophysics, including exoplanet detection, astrobiology, and the search for technosignatures of advanced civilizations. Kipping's passion for his field is evident as he discusses the intellectual challenges and excitement of working at the frontiers of human knowledge. He demonstrates a willingness to engage with big questions about our place in the universe while maintaining scientific rigor and skepticism. The podcast with Dr. David Kipping offers a wide-ranging exploration of cutting-edge topics in astrophysics and cosmology. From the search for extraterrestrial life to the nature of dark matter and dark energy, the conversation highlights both the tremendous progress made in our understanding of the universe and the profound mysteries that remain. Kipping's approach emphasizes the importance of intellectual honesty, open-mindedness, and rigorous scientific inquiry in tackling these fundamental questions about our cosmic context.